Hi, today we are going to work some examples from R.3, and in this example we're going to do numbers 8, 12, and 20. Let's go ahead and start here with number 8. Reading the directions from the book, it says find the domain of each rational expression. First of all, if we just had the numerator, which is 9x plus 12, that would be a diagonal line. Okay, it has a slope, it has a y-intercept. Diagonal lines actually have a domain that is from negative infinity to positive infinity. But because we also have the denominator here, and we know that in mathematics you can't divide by 0, you have to figure out what's going to make each factor turn into 0 in the denominator. So you're going to have to let 2x plus 3 equal 0. And you're going to have to solve that problem. Well, 2x equals negative 3, and x turns out to be negative 3 over 2. Now, that is an x value that x cannot equal, okay? X cannot be negative 3 over 2, because if it is, right here, then when you do 2 times negative 3 over 2 plus 3, you get 0. And 0 times anything is 0. And you divide by 0, this, I like to say, blows up. So you cannot have x being negative 3 over 2. At the same time, you have to check out the other factor. You got to let x minus 5 equal 0. And this one turns out to be x equals 5. So therefore, x cannot be 5 either, because 5 minus 5 is 0. 0 times anything is 0. And when you divide by 0, it doesn't work in mathematics. So your final answer for your domain turns out to be all the answers from negative infinity to negative 3 over 2, close it, union, the other side of negative 3 over 2, all the way up until it gets to the number 5, close it, union, and then the rest of the answers are good all the way from 5 to infinity. And remember, we did use parentheses here to symbolize that these numbers are not included in the domain, and that answer is number 8. I'm going to go ahead and bump it on to number 12. Reading the directions, write each rational expression in lowest terms. Remember, you cannot reduce, like for instance right here, you cannot reduce 10 and 15 because they're next to plus signs. Anything directly next to a plus sign or a minus sign, you will not be able to reduce. You can only reduce when they're next to multiplication signs. So therefore, since this term, which is 20r, that's one term, and it's next to a plus sign, you are not allowed to reduce with 30r, which is next to a plus sign. So we're going to have to use a little factoring to actually reduce this. We can pull out the greatest common factor of the numerator, which is 10. What's left? 2r plus 1. The denominator, we can factor out of 15. And that means we're left with 2r plus 1. Now you look at the numerator and denominator. As long as I can take the entire term, okay, the plus sign included, see there, right now these two have multiplication signs between them. So therefore, I'm allowed to take this entire term and reduce it with this entire term. Okay, that is a legal thing to do. Also over here, I'm noticing that 10 and 15 will be the only ones left, and 5 goes into 10 twice, and 5 goes into 15 3 times. So the only thing left out of all of this is 2/3. And that completes number 12. It is reduced. Now we have number 20, similar situation, except for this time it is a trinomial. Trinomial means we're going to have to do a little factoring by trial and error. So the signs have to be plus and plus. It's got to be what times what makes 6y squared. Well, you could have 3y and 2y. 3y times 2y is 6y squared. It could be 6 and 1. I'm not sure. I'm going to go to the end here. You got to have a 4 times 1 or 2 times 2. Now let's see. If I put in 2 times 2, let's check that first. That means the outside is 3y and 2y, or 3y times 2, which is 6y. and the inside is 2 times 2, which is 4. 6 and 4 adds up to 10, but we need 11. So that doesn't quite work out for us. So we need to try something different. First of all, you can switch 2 and 2, but that doesn't really do us any good here. So I'm going to try the other case, which is 4 and 1. Let's try that out. The outside is 3 times 1, which is 3. The inside is 4 times 2, which is 8. 8 and 3 adds up to 11. Bingo, we got that one. Down to the denominator. We're going to factor that by trial and error. It ends in a plus sign. It's plus in the middle. This one's the most basic case, which is plus plus. We have 3y squared, which is 3y times y. And we have the number 4, which is either 2 and 2 or 4 and 1. Well, I'm noticing that 4 and 3 adds up to 7. So I'm going to try to set it up so that the 4 and the 3 do not multiply each other. This is 3y, and this is 4y, and that adds up to 7y. So that means we have it factored. So now you look and you see, is there any, see, this is the multiplication sign. Anything to the left or right of this multiplication sign can be completely canceled. So I'm looking at it going 3y plus 4, 3y plus 4, they each cancel. These two are not alike, so they are left in the answer, which is 2y plus 1 divided by y plus 1. And that fraction is reduced. And that completes number 20. And that completes the video for this particular part.